Welcome everyone, and let's start a new topic, that is the ionization energy. Sometimes ionization energy is also called as the ionization potential. So at +2 level or FSC level, there is no difference between the ionization energy and ionization potential. What is ionization energy? It is the energy which is required to remove an electron from an isolated gaseous atom to form a gaseous positive ion. Keep one thing in your mind, that this one is isolated gaseous atom. In its ground state. What is meant by isolated gaseous atom? Gaseous atom means it will be in gaseous state, and isolated means that there will be no intermolecular or intramolecular forces this atom will have. So this is an isolated atom. No intermolecular forces or no intramolecular forces with any other atom. And when you want to remove the electron, then some energy is required to overcome the nuclear force of attraction, and that energy is called as the ionization energy or ionization potential. So here will be its ionization potential, that will always be positive because removal of electron is always an endothermic process. Keep one thing in your mind, that it is very important to know that this state will always remain gaseous in both these cases. If the state in any case will be changed, that change will not be the ionization energy. Suppose that I am writing here that A atom is in solid form, loses electrons and form positive gaseous atom. This is not a change for the ionization energy. If it is gaseous but here liquid is written, this change will not represent the ionization energy. So in case of ionization energy, both the atom and the positive ion, they must be present in the gaseous form. Now keep one thing in your mind, that suppose we have magnesium atom and we remove an electron out of it to form the unipositive ion. In this particular case, the ionization energy will be round about 738 kilojoule per mole. But when we will remove second electron out of its unipositive ion to form the dipositive ion, then the second ionization energy, this one is the first ionization energy and here is the second ionization energy, that will be around about 1550 kilojoule per mole. Please confirm these values from your book. So that is the first ionization energy, second ionization energy. But when we want to remove third electron from this dipositive ion to form the tripositive ion, the third ionization energy will be around about 7738 kilojoule per mole. So second ionization energy is greater than first ionization energy. In the same way, the third ionization energy is greater than the second ionization energy. It means I can write it down that the third ionization energy is greater than second ionization energy. It is greater than first ionization energy. It is not true only in case of magnesium, but in case of all atoms in the periodic table. As we move towards the higher ionization energy, their values will be much greater as compared to the lower ionization energy. Why it happens? Just because of the reason that the nuclear force of attraction on the electrons that keep on increasing as we remove the electrons from the atom. Suppose that a husband and wife, they have three kids, they have three sons, and one of the sons is unfortunately kidnapped by some kidnapper. What do you think? That their attention on the remaining two sons, that will be much increased, and their attraction on the remaining two sons, that will be increased. In the same way, when we remove an electron from an atom, the nucleus plays the role of the parents. Its attraction on the remaining electrons, that increases. Its grip on the remaining electrons, that increases to a greater extent, due to which the higher ionization energy values are always greater than the lower ionization energy values. Now, what are the factors that affect the ionization energy? The factors that control the ionization energy. The first one is the atomic radius. Second one is the shielding effect. The third one is the effective nucleus charge, and fourth one is the penetration effect. Now, what are the relationship of these factors with the ionization energy? As far as the atomic radius is concerned, that is inversely related to ionization energy. Mean greater the atomic radius, lesser will be the ionization energy. What is the reason behind? Just because that when the atomic size will be very large, then the nuclear grip on the valence electrons, that will be weak. So lesser energy will be required to remove the electron from the larger atom as compared to the smaller atoms. Shielding effect, that is also inversely related to ionization energy. Now there are some students that have no idea that what is the shielding effect. Let me explain with a very simple example. That suppose we have sodium atom. You know there will be 11 protons and 12 neutrons in its nucleus. The first shell, then the second shell, and then the third shell. The first K shell will be having 2 electrons, second L shell will be having 8 electrons, and the third M shell will be having 1 electron, total 11 electrons. Now, there is nuclear force of attraction because this nucleus is positive, this electron is negative, so there will be nuclear force of attraction on this valence electron. But this nuclear force of attraction on the valence electron is reduced because of presence of these 10 electrons, 2 electrons in the K shell and 8 electrons in the L shell. So the presence of these 10 electrons has reduced the nuclear force of attraction on the valence electron. This is called as shielding effect. Shielding effect is actually the reduction in the nuclear force of attraction on the valence electron due to presence of the intervening electrons. Intervening electrons are these electrons in this particular case which are present in the K and L shell. Sometimes these electrons, they are also called as the core electron, and this electron is the valence electron. So greater the shielding effect, the nuclear force of attraction will be further reduced on the valence electron. When the nuclear force of attraction will be further reduced, then it will be very easy to remove that electron and the ionization energy will be decreased. Z effective, directly proportional to ionization energy. Now, when I say that Z effective is directly proportional to ionization energy, what is meant by the Z effective? The formula of Z effective is Z effective is equal to Z minus S. Now, what is Z? that is the proton number or the atomic number of an atom. And what is S? That is the shielding effect. Now listen it very carefully. That as we move from left to right in a period, the atomic number increases, but the shielding effect remains constant, because in a period the number of shells remain constant. So Z keeps on increasing and S remains constant. This happens in a period. That's why the Z effective that also increases. But when we move from top to bottom in a group, listen it very carefully, that when we move from top to bottom, Z increases, but at the same time S also increases, because when we move from top to bottom in a group, the number of shells they keep on increasing. So the shielding effect also increases. Z increases, S also increases. So Z effective remains almost constant. So keep one thing in your mind, that Z effective is important only in a period. It is not important in a group. Because in a group the Z effective will remain constant, but in a period the Z effective will keep on increasing. So greater the Z effective, stronger grip will be there. Stronger nuclear grip on the valence electrons will be seen. So it will be difficult to remove the electron and the ionization energy will increase. Penetration effect. This is very important. Now, what is penetration effect? Basically, penetration effect is the fraction of time for which an electron remains in a subshell nearest to nucleus. For how much time the electron remains nearest to the nucleus in a subshell, that is called as its penetration effect. Now, penetration effect of S is maximum, then P, then T, and the minimum is of F subshell. What does it mean? It simply means that if an electron is present in S subshell, it will spend more time nearest to the nucleus as compared to the electron which is present in P subshell. So suppose that we have fourth shell, and in fourth shell there is 4s and 4f. Electron is present in 4s and the electron is present in 4f. Which electron will spend more time nearest to the nucleus? The electron which will be present in the S subshell. That is why the electron which is present in S subshell, that is difficult to be removed. Why the electron which is present in P subshell, it is easier, then D further easier, and F, that is the easiest to be removed. That's why much higher energy will be required when the electron will be present in the S subshell, and very less energy will be required when the electron will be present in the F subshell. But here again there is a very important and very critical point, that this penetration effect is again only important in case of a period. It is not important in case of a group, because all the members of one family or all the members of one group, their valence electrons are present in the same subshell. So penetration effect will not be important. But when we move from left to right in a period, then the subshell goes on changing, and when the subshell is changed, then the penetration effect comes into consideration. Penetration effect will be considered only when we will be discussing the change in ionization energy in a period. So these are the factors that affect the ionization energy. What is the trend of ionization energy? Obviously, as we move from top to bottom in a group, ionization energy decreases. So the element that will be present on the top of the group, that will be having maximum ionization energy, and the one which will be present at the bottom of the group, that will be having the minimum ionization energy. In the same way, when we move from left to right in a period, ionization energy increases. So it means the elements that will be present at the left of the periodic table, they will be having very less ionization energy, and the elements which will be present at the right corner of the periodic table, they will be having the maximum ionization energy. Now I am giving you a very important point, that at the left of the periodic table there are alkali metals, and at the rightmost corner there are noble gases. So it must be clear to us that in a period the minimum ionization energy will be of alkali metals, while the highest ionization energy that will be of the noble gases. So keep this thing in your mind, that the minimum ionization energies of alkali metal, while the maximum ionization energies of the noble gases. Now, it means when I say that ionization energy increases when we move from left to right in a period. So the trend that must be observed, if I can draw a graph for you people. Suppose here is the period number, ionization energy. So this one is 1A, 2A, 3A, 4, 5, 6, 7, 8. Because according to the normal trend, ionization energy increases from left to right. So the normal trend should be like this. As we move from left to right, the ionization energy must be increased. The minimum should be of alkali metals, and the maximum should be of the group 8A, or the noble gases. This is the expected way of the change in the ionization energy. But in real, this is not seen, that as we move from left to right, the ionization energy gradually increases, but there are certain exceptions. Now, what is the actual order? This one is the actual order. One A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. This one is actual change in ionization energy when we move from left to right in a period. What does it show? It shows that ionization energy of group 2A is greater than group 3A, and ionization energy of group 5A is greater than ionization energy of the elements of the group 6A. So these two groups, they show exceptional behavior, the group 2A and 5A, and these two groups 3A and 6A, they show abnormal behavior. It is a very important MCQ here, that what are the groups that show the exceptional behavior and what are the groups that show the abnormal behavior. Now I will explain in one line what is meant by the exceptional and abnormal behavior actually. Exceptional behavior means that the ionization energy of 2A must be greater than 1A according to the normal trend. But as far as our expectation is concerned, the ionization energy of 2A is much more increased exceptionally. So it is exceptionally high. Now, similarly, when we move from 4A to 5A, the ionization energy must be increased, but it is much more as compared to our expectation. Means again there is an increase, but there is an exceptional increase, very much increase. This is the exceptional behavior, mean their ionization energy is increased, but that is exceptionally increased, exceptionally very high. What is meant by the abnormal behavior? Abnormal behavior means that no matter how much high ionization energy elements of the group 2A have, according to the normal trend, the group 3A must have greater ionization energy as compared to the 2A. But they have lesser ionization energy, so that is their abnormality. And in the same case, the 5A, elements of the 5A, they have very high ionization energy. But even if they have exceptionally high ionization energy, the ionization energy of the 6A must be even greater than 5A according to the normal trend. But it is decreased, so that is the abnormality in the 6A. Now, why it happens when we move from 2A through 3A? It is the mystery lies in the electronic configuration. Let us write down the electronic configuration of magnesium. That is an element of the 2A. 1s2, 2s2, 2p6, 3s2. And let us write down the electronic configuration of aluminium. It is an element of the group 3A. 1s2, 2s2, 2p6, 3s2, 3p1. Now you can easily understand that why the ionization energy of magnesium is greater than aluminium. Now keep one thing in your mind. It is S block, it is P block. So when we move from 2A to 3A, the block changes actually. Its valence electron are present in S subshell, its valence electron is present in the P subshell. Listen very carefully. That I have already mentioned that to remove electron from S subshell is much difficult as compared to P subshell. So that's why here the ionization energy is exceptionally high. Why here the ionization energy is exceptionally high? Because we have to remove the electron from the S subshell. And on the second number, these electrons are paired. So there are two factors. In magnesium, the electrons are present in S, that makes them difficult to be removed, and secondly, those electrons are paired. It makes it further difficult to be removed as compared to the aluminium. Now listen, when we remove first electron from magnesium, now it is 3s1, and we also remove first electron from aluminium. Now they are both unipositive, and that is 3p0. Now which one of the following will have second high ionization energy? Second ionization energy of which of the following will be higher? You can easily see that now the aluminium has the same electronic configuration as that of the magnesium. So now the second ionization energy of the aluminium positive, that will be much greater as compared to the magnesium positive. So that is again a case. Now let us see the 5A and 6A. In 5A, I will write down the electronic configuration of nitrogen, and in 6A, oxygen. So 1s2, 2s2, 2p3, 1s2, 2s2, 2p4. Why the nitrogen, which is an element of group 5A, it has higher ionization energy as compared to oxygen, which is an element of the group 6A? Because here the P is half filled, and you know there is some extra stability which is associated with the half filled subshells. So that's why the nitrogen will be having high ionization energy as compared to the 6A. And it is not nitrogen. All elements of the 5A, they have more ionization energy than 6A, just because of the extra stability associated with their half filled P subshells. So it is about the exceptional and the abnormal behaviors in the ionization energy. At the end, I will like to mention that what is the importance of the ionization energy, concept of the ionization energy. Number one, ionization energy is directly related to stability of atom, means ionization energy is a quantitative measure to find the stability of an atom. So greater the ionization energy, we will say that more stable is the atom. It means noble gases have highest ionization energy, so they will be having maximum stability. While the alkali metals have lowest ionization energy, so their stability will be minimum and their reactivity will be maximum. And you already know that alkali metals are the most reactive metals of the periodic table. Ionization energy is also a criteria to check the metallic character, and metallic character is the easiness to lose the electron. So ionization energy is inversely related to the metallic character. Mean greater the ionization energy, lesser will be the metallic character. So when we move from top to bottom in a group, the ionization energy decreases, so metallic character increases. In case of alkali metals, lithium will be showing the least metallic character, while the cesium and francium, they will be showing the maximum metallic character. And in the same way, when we move from left to right in a periodic table, the elements at the left, they have low ionization energy, so they are all metals. And the elements at the right, they have high ionization energy, and most of them they are the non-metals. Third is ionization energy can also be related to find the valency of atom. Suppose that I am giving you a data that there is an element, its first ionization energy, these are the supposed values, that is 700 kilojoule per mole. Its second ionization energy is 1550 kilojoule per mole. Third ionization energy is 7738 kilojoule per mole. These are the supposed values. Now what is the valency of this atom? Basically, whenever you are required to find the valency from the ionization energy, you will see where there is a huge gap of the ionization energy. In first and second ionization energy, there is huge gap, but that is not as much as there is a gap between the second and third ionization energy values. So here the gap is very large. When the gap is very large, then those ionization energies in which gap is larger, their lower value will be the valency. So here the valency of this atom, that is 2. In case of why this gap at once increases, because when we remove the second electron, now this atom gains the electronic configuration of the noble gas, and then to remove the electron from noble gas, that at once becomes very difficult, and the ionization energy also increases. So keep one thing in your mind, that in case of alkali metals, listen very carefully, that in case of alkali metals, the ionization energy gap will be maximum between the first and second. In case of 2A, alkaline earth metals, the maximum gap will be between second and third. In case of boron family, the maximum gap will be present between the third ionization energy and fourth ionization energy. So where there will be huge gap, the lower number will be showing the valency of the atom. Now, after the whole discussion of the ionization energy, what do you think that which element has maximum ionization energy in the periodic table? According to me, I think so helium, because it is present at the rightmost and at the topmost of its group. Rightmost in the period, topmost in the group. And which element will be having lowest ionization energy? That will be cesium and francium, because they are present at the leftmost in the period and bottommost in their respective group. So this was all about the discussion of the ionization energy. Take care. Allah Hafiz.